In this video, we're going to do some examples on how to factor trinomials when the a coefficient is 1. Okay? When the a coefficient is 1, it's just read as x squared plus bx plus c. Okay, we don't really need to say 1x squared. That's understood that that coefficient will be 1. So, all right, let's look at our first example. Okay? And what I want you to concentrate on is the C constant, all right? And we're going to put that over here, and I want you to list all the factors. So list all factors. Let me write that better, apologize, my pen keeps slipping. Of 10. So what does that mean? Well, think of all the combinations of numbers you can multiply to get 10. The first one is 1 times 10. The second combination is 2 times 5. Okay, those are the only possibilities, only two combos that we can get to get 10. And we want to pick the combination so that when you get the middle term, and the middle term here is 7x. So what we do is we're going to choose those two factors, okay? Now, some of these you can do just by breaking it up. Okay, what I mean by that is you can just say, okay, you can just say, write your two sets of parentheses, all right? And you can say, what times what is x squared? Well, x times x would be the only thing to give you x squared when you add the exponents of 1, right? And then we decided to pick 2 and 5, okay? So we're going to pick 2 and 5, and you put it here. And why do we do that? Because 2 and 5 actually give me 7 when I add them. And if the trinomial is both plus, see how it says plus 7x and plus 10x? Then you can just put plus plus here, and then that would be your two factors. So if you FOIL this out, you're going to get x times x is x squared, x times 5 is 5x, and x times, let me FOIL it out for you, x times x is x squared, x times 5 is 5x, and then you do the inner, 2 times x is 2x, 2 times 5 is 10. And if I combine the middle terms, 5x and 2x is in fact 7x plus 10. Okay, that's one way you can do it. You know, if it's easy enough that you can just fill in the parentheses, that's fine too. Okay. If you're having trouble with that, then you can do the little bit longer way. The longer way is a little bit more methodical, and you do it every time. There's really no guesswork. The only thing is you got to pick the right combination to give you the middle term. All right. So if you want to do it that way, that's fine. Here's another way you can do it. Another way is you can write down your first term, leave a little space, write down your last term including the sign. And we agreed that we still need to pick 2 and 5. So we're going to call that 2 and 5. We're going to put it in the middle. And since x is our variable, we're just going to call that 2x and 5x. Now I just need to know what the signs have to be in order to get a positive 7. Well, positive 2x and a positive 5x is the only way to get a positive 7x in the middle. And then what I do is I go factor by grouping. Okay, and then I do the GCF on both sides like I showed you in the previous video. If you do it this way, then you'll get the same answer, all right? What's the GCF on the left side? Well, it's going to be x, because we're picking the lowest exponent, which is 2x squared, so just pick x. 2x, and if you just pick x, all right? If you have x squared and I take one of the x's out, then I should have 1x remaining. If I have 2x and I take the x out, then the 2 stays behind. All right, then you take the GCF out on the right. You notice that the plus 5, so we're going to put a plus here. What is the GCF between 5 and 10? Well, 5 is the largest number we can take out. The x stays behind, and then 5 times 2 is the only way to get 10. You notice that these are the same. We want to make sure those are the same, including the signs, because that's going to be my GCF that I factor out. And you notice I have x and plus 5. Well, that goes in my own set of parentheses. So now I have, that is my answer. Okay. Over here to the right, I did trial and error. Okay, where you can just guess the factors of 10 that would work to give you 7. Okay, so when you think, okay, 2 times 5 is 10, and then 2 plus 5 gives me the 7. And you can just fill in the parentheses and be done. For some of these, you can do that, and that's what I recommend for the easier ones. But if you're struggling with that and you just need a more methodical method, then do the way that I did on the left. It's a little bit longer, but it gets you the right answer. Or you just have to be good with factor by grouping and the concept of taking a GCF out. All right, so, and that's why learning the GCF and factor by grouping first is so beneficial to when you factor trinomials, because you can actually use it to help you. Trial and error is good if the numbers are small, but if you have very large numbers, okay, you have to think of an alternative to make it more practical. And so we got to be careful on what method to use depending on what numbers we have, because it can make a big difference. If you're trying to factor a 3-digit constant, then maybe trial and error is going to be a little difficult because you have so many combinations. Okay, so just kind of keep that in mind. All right, so let's do a couple more. Okay, so here we have x squared minus 2x minus 63. Okay, so what we're going to do is we're going to find all the factors of 63. Okay, now again, when you do this, all right, you have to find the factors, all the numbers that divide into 63. So we can do that over here. All right, we can do 1 and 63, and then 63 divided by 3 is going to give you 21. So then we have 3 times 21. Okay, and then 4 doesn't go into 63. 5 doesn't. 6, okay, doesn't go into it because you're going to get a remainder. 7, however, does. So 7 times 9 will give me 63. And that is the one that I'm going to be looking at. Okay. So I actually had this paused. So anyways, when I was doing this problem, I chose 7 times 9 as my 2 factors. So I'm going to have to rewind this here because I had it on pause and I didn't realize that. So I need to re-explain it one more time. Okay, I think I accidentally hit the button, and as I was speaking, it was on pause and wasn't recording, so I'm just going to redo the problem just in case. What I was basically saying is I listed all the factors of 63, and then I chose 7 and 9 because the difference between 7 and 9 gives me the middle number 2. Okay, so what I did is I went ahead and wrote down my first term, wrote down my last term, and then basically I chose 7 and 9. Notice I left a little space to put 7 and 9 in there. Since x is my variable, I need to make that 7x and 9x. Now I just need to know, how do I get minus 2? The only way that can happen is the 7 has to be positive and the 9 has to be negative. 7 minus 9, in fact, gives me the negative 2. So you've got to pick the right signs to get that middle coefficient, including the sign, okay? Now, when we do factor by grouping, we split them down the middle. So we have one group on the left and one group on the right. So the 2 terms on the left, we need to take out the GCF. And again, if you look at the exponents, x to the first power is what we're going to take out. And of course, if I take out an x, then this reduces to x plus 7. The 7 stays, and then x squared, if I take one out, that reduces to x. Look at the group on the right, there's a minus 9. You notice that coefficient is negative, so we're going to factor out that negative. And it looks like 9 is the biggest number that goes into 9 and 63. You notice the x stays inside. A negative times a what is a negative? Well, the only way to get a negative 63, it has to be a positive 7. Okay, and you notice that these are identical. So now we have x plus 7 is one of my factors. And then, of course, your x and your minus 9 goes in the other set of parentheses. And then I have my 2 factors. So it can be done fairly easily with that method. Okay, it's very methodical, and it kind of teaches you a little bit about the structure of a polynomial, where we break it up into 2 separate groups because we have 4 terms now. It's just a different approach. Okay, could you have used trial and error? Sure. If you realize that 9 times 7 is 63, and then you say, okay, 7 and 9 gives me a difference of 2, then you just figure out the signs. You notice that a positive 7 times a negative 9 is the only way to get a negative 63. So when you FOIL it, you should get x squared minus 2x minus 63. For the easy problems, trial and error is the way to go. But if you're having problems with that, don't beat yourself up over it. Just say, you know what, let's do it the longer way for now until you start catching on, and then you will eventually see that you won't need to do it like this all the time. So I'm just opening up another avenue so that you can go around it when you're stuck, okay? And then you can always go back and say, okay, this is what they meant by trial and error, okay? That's what's so cool about math, is that you can have different ways of doing things and we all get the same answer. All right, so being open to learning new ways is one of the key, in my opinion, one of the key ideas to be successful in solving a lot of different problems in your classes. All right? Okay, so I think we should do another one. Okay? So here we have x squared minus 8x plus 12. All right, this one's a little simpler because of 12. We want to find all the factors, so I like to list them in order, starting with the greatest spread, 1 and 12, 2 times 6, and 3 times 4. Those are the only possibilities that will give me 12. Now I just need to pick a combination so that I can get 8. I know all of them give me 12 when I multiply, but only one of them, in this case, gives me the minus 8. And can you guess what that is? It's actually going to be the 2 and the 6. All right? So write down your first term. Write down your last term. Leave a little space, and then write 2 and 6. All right, since x is our variable, we need to add the x there as well. Now I just need to know what the signs have to be to get minus 8. The only way that could work is that if you start with negative 2 and take away 6 more, you in fact get negative 8. So all we got to do now is factor by grouping, by splitting them down the middle into 2 groups. Take out the GCF on the left first. Again, x is going to be my GCF. Pick the smallest exponent, right? There's a 1 here. And then everything else gets remained left in the parentheses. So one of the x's stays, minus 2 stays. Okay? Because x times x gives me x squared, and x times minus 2 gives me the minus 2x. Leading coefficient of 6 is negative, so that needs to be factored out. And again, 6 is the GCF here. That's the biggest number that divides into 6 and 12. And then 6 times what is 6x? The x is left behind. And of course 2 would work because negative 6 times 2 is 12. Notice that, excuse me, I made a mistake. the sign. It should be a negative 2, because a negative times a negative is a positive 12. Okay, so we have to be extra careful with those signs. It's so easy to miss. I mean, just shows you how careful you have to be. But as long as we catch it, that's all that matters. All right. Now, what is the GCF? It's really x minus 2. But we couldn't really tell until we factored it out. You see that? So since x minus 2 is common on both sides, 1 needs to be factored out. Okay, just factor it out. And then now the x and the minus 6 go in their own set of parentheses. And then this is the answer. Okay. All right. So let's do another one. Okay. What are all the factors of 9? Well, you got 1 times 9, and then 3 times 3. And you can clearly see that 3 and 3 give me the 6. So that is the option that we want. So let me just show you a couple things here. Let me just continue doing it like the way I showed you, and then I'm going to show you something after that. Okay. So write down your first term. Write down my last term. Leave a little space, and then we're going to put 3 and 3 here. So we're going to call that 3x and 3x. What do the signs have to be for the 3's in order to get a positive 6? Well, positive 3 plus 3 is positive 6. Split them down the middle. Take out the GCF, which is going to be x. Again, you're left with x plus 3 on the inside. On the right, the leading coefficient of 3 is positive, so we're going to take out 3. And then you're going to be left with x plus 3. Again, I factored out a 3 because 3 is the biggest number that I can divide into 3 and 9 evenly. The x stays, and then 3 times 3 is the only way to get the positive 9. All right. You notice my GCF is x plus 3, so that needs to be factored out. And then the GCF of x and 3 here go in their own parentheses. And that is your answer. Now, as a little footnote, this trinomial, okay, believe it or not, so let's write it over here, x squared plus 6x plus 9. This is called a perfect square, okay, trinomial. What does that mean? It means that x squared is a perfect square because x times x is being multiplied itself. A perfect square means something times itself. Okay, 9 is also a perfect square because you have 3 times 3. You notice 3 is multiplied itself. And the middle term is going to be 2 times that factor of 3. Okay, so the middle term, which is 6, is going to equal 2 times one of those factors, okay? So since 3 is the same, we just pick one of them. 2 times 3 is 6. And that pattern is always going to occur. It's called a perfect square trinomial. So if you try to factor it, all you got to do is say, okay, what times what is x squared? Well, we said x times x. What times what is 9? We said 3 and 3. And if both sides are positive, then both of these have to be positive, and we get the answer. Okay? So perfect square trinomials are very easy to spot when the c constant is multiplied itself, and then the first term is also multiplied itself. So x times x, which is x squared, and then the last term is 9, so 3 times 3 gives me 9. So both of those, A and the C term, are perfect squares. It will always form a perfect square trinomial. Okay? So I just wanted to mention that. All right. Okay, so that is a video that shows you how to factor trinomials when the A coefficient is 1. Thank you so much for watching.